All right, hey guys, so this video is all about the new derivative rules. So these are really the last rules that we have to learn in order to be able to take derivatives of functions. So the first thing we're going to do is the trigonometric derivatives. I need you guys to take a look at this notation here. All right, this first one says d dx sine u. So if you notice, there's actually not even an x in this function. So I want you guys to really quickly just make a note that u is a function of x. So really, this u on the inside really just stands for a function that's in terms of x. So it helps us worry about the chain rule if we need to, all right? So the derivative of sine is just the cosine of u times du dx. This du dx takes care of the chain rule. So for example, if we were going to just take the derivative of sine of x, the derivative of sine is just cosine of x, and we would be done. But if the inside of that sine function is something different, so let's say d dx of sine of 2x, then now on the inside we've got this 2x. So that's going to require some chain rule. So we take the derivative of the outside, which is cosine, and remember the inside stays the same, and then multiply by the derivative of the inside, which in this case is 2. All right, so that's where this u is kind of coming from. I hope that helps a little bit with the notation. We'll do a lot of examples and we'll talk about a lot of different problems, so you'll be fine. The derivative of cosine is negative sine u times du dx. Tangent is secant squared u times du dx. So really, the derivative of tangent is secant squared, and then this du dx again is just the derivative of the inside. That's helping take care of the chain rule if it's necessary. The derivative of cosecant is negative cosecant u, cotangent u, and then all times du dx. So again, the derivative of the inside. The derivative of secant is secant u tangent u du dx. And the derivative of cotangent of u is negative cosecant squared u times du dx. These are just things you're going to have to memorize, guys. So all of the rules that I introduce in this video are rules that you're just going to have to memorize. I know it's not ideal. I know it's not fun to memorize, but these are definitely ones you're going to have to memorize these rules. All right, but let's do some examples. So if f of x is cosine of 3x, then f prime of pi over 9 equals, and we've got these multiple choice answers. So the first thing we're going to have to do is actually find f prime of x. So f prime of x, well, the derivative of cosine is negative sine. So it's negative sine of 3x, because the inside's not going to change. And then we're going to multiply by the derivative of the inside, which is 3. So that means that f prime of x is negative 3 sine of 3x. Now this is asking for f prime of pi over 9. That means we're going to substitute pi over 9 into our function. So negative 3 sine, and if I do 3 times pi over 9, I get pi over 3. So now I have negative 3. The sine of pi over 3 is root 3 over 2, which means my answer is negative 3 root 3 over 2. So if I look, that is choice E. All right. For question 2, it looks like we've got some product rule going on there. So y equals x squared sine 2x. We're looking for dy dx. So this one we're just looking for a general derivative. So remember our product rule. So dy dx equals, we're going to take the derivative of the first, which is 2x, times the second, which is sine of 2x, and then plus the derivative of the second. So the derivative of sine of 2x is cosine 2x, because the derivative of sine is cosine, and the inside stays the same. Then we're going to multiply by the derivative of the inside, which is 2x. So the derivative is 2. And then we're going to multiply by x squared, because we can't forget that that was our original function. All right, so if we simplify this a little bit, we have 2x sine 2x plus 2x squared cosine 2x. Oops, I ran out of room. Sorry. Well, if we look here, this does not match any of these right now, so we're going to have to find an equivalent form. So it looks like both of them have a 2x, so I'm going to factor that out. So I get 2x sine of 2x plus x cosine 2x, which means my answer choice is E. All right? Those are our trig functions. All right, so now we're going to look at the derivatives of exponential and logarithmic functions. So before we do that first one, though, I want you guys to actually change it for me. We are going to change this to say d dx of, instead of 2 to the u, we're going to make it a to the u. Because it doesn't have to just be a base 2. It can be base anything. All right, so the derivative of an exponential is the original one again, so au, a to the power of u, times the natural log of u times the derivative of the inside, so the derivative of the exponent, so times du dx. All right, I promise it'll make more sense when we do an example. It looks really funky, but the derivative of an exponential is itself times the natural log of u times du dx. Okay? Looking at the derivative of e to the u, well, e to the u is really just a special case of an exponential, which means the derivative of e to the u is also e to the u. And then we would technically do times the natural log. This should be a. I'm sorry, you guys. I'm all over the place today. A to the u times the natural log of a times du dx. Now for this one, it's e to the u because it's the original, times the natural log of e, which is really just 1, and then times du dx, which is really nice because that means that the derivative of e to the x is just e to the x, and there's nothing else you have to do with it. It's kind of nice. Then when we do a log, again, I want you to change this 2 to an a. All right, so it's log base a of u. The derivative of a log function is 1 over u, so whatever's inside the log, times the natural log of the base, so the natural log of a, and then times du dx. So again, this du dx is helping us account for the chain rule. All right, then the derivative of a natural log, again, that's just a special case of log base au. This is really kind of like saying log base e, okay? So the derivative of a natural log is 1 over u times du dx. This one, we don't need a natural log because it would be the natural log of e, which is just 1. All right? Let's do some examples with these ones because these ones I think are a little bit harder. So, for question 1, f of x is e to the 2 over x. So f prime of x, Well, if I have e to some power, my derivative is the original function. So that means e to the power of 2 over x, and then times du dx. So I want the derivative of whatever my exponent is. So I want the derivative of 2 over x. All right. Well, 2 over x, remember, if we need to rewrite that, 2 over x is the same as 2 times x to the negative 1, which means to take the derivative of that, we can just use power rule. So 2 times negative 1 is negative 2, and then x to the negative second, because we subtract 1. Now that looks a little gross, so let's rewrite it a little bit. I'm going to do negative 2 over x squared, and then e to the power of 2 over x. And we need to see if that's an option here. So it's definitely not a blah, blah, blah. Well, let's see. Here we go. D is the correct answer there. Okay? Then let's look at question 2. So question 2 says f of x equals the natural log of x squared. We want to find f prime of the square root of e. So first thing we need to do is actually find f prime of x. And if you notice, we're going to need some chain rule there because this is something squared, which means the squared is the outside function. So we're going to drop the 2 and leave the inside alone, so the natural log of x, and subtract 1 from the exponent, so really there's a 1 there. We don't have to write it though. And then we're going to do times the derivative of the inside. The inside is the natural log of x. So the derivative of natural log of x is 1 over x. And then technically we need to apply the chain rule. The derivative of the inside, which is just x, is really just 1. Okay, so for this one, we get that f prime of x is 2 times the natural log of x over x. Now we want to actually evaluate f prime of the square root of e. So this is 2 times the natural log of the square root of e over the square root of e. Now we're going to have to use some rules for logs and exponents here. The natural log of the square root of e, I'm just going to go over here and do this, is really like saying the natural log of e to the 1/2. All right, well, the natural log, hopefully you guys remember, that's just a fancy way of saying log base e. So in other words, e to what power gives me e to the 1/2. So that means this right here really just becomes a 1/2. All right, so 2 times 1/2 actually just becomes a 1 on the top. So it's 1 over the square root of e. That's our answer there. So this answer is D. All right, I know that's a little weird. That's definitely using some of our algebra skills that we haven't used in a while, but we can talk about it in class if we need to. Okay? All right, I know this is a lot. This is kind of a longer video. I'm glad it's a weekend at least, so that you guys have some time to process it if you need to. The last thing we need to talk about is the derivatives of inverse trigonometric functions. These are another one you have to memorize, and these are a little bit hard to memorize. To be honest, it takes me a while to remember them each year. So let's just go ahead and get started. D dx sine inverse of u is 1 over the square root of 1 minus u squared times du dx. And again, remember, u is just a function of x, so this du dx is helping us take care of the chain rule if it's needed. All right? Cosine inverse of u, it's really nice because it's actually just the negative of the sine inverse. So it's negative 1 over the square root of 1 minus u squared du dx. Tangent inverse is 1 over 1 plus u squared times du dx. And then it's nice because actually tangent, cotangent inverse is just the negative of that. So it's negative 1 over 1 plus u squared du dx. Again, these are just things we have to memorize, unfortunately, guys. They're ugly, I know, but got to deal, okay? Secant inverse of u, so the derivative of secant inverse is 1 over the absolute value of u times the square root of u squared minus 1, and then times du dx. And cosecant is just the negative of secant inverse. So it's negative 1 over the absolute value of u times the square root of u squared minus 1 times du dx. Okay, that's a lot. I know, they're kind of ugly. I'm sorry, but got to memorize them. So let's do some quick examples, and then I'm going to let you guys go, and we'll do lots of practice when you come back to class. So if f of x is sine inverse of x to the third, find f prime of x. So f prime of x, we're going to need sine inverse, which is 1 over the square root of 1 minus u squared. Okay, but the u is actually x to the third. Okay, and then we're going to have to do times the derivative of u. So the derivative of x to the third is 3x squared. That means then that f prime of x is just 3x squared over the square root of 1 minus power to a power we multiply. So this is x to the sixth. And that's our final answer for number 1. All right, so we just use the formula, which is nice, and then apply the chain rule. Then we've got one more. We've got the secant inverse of 2x. So dy dx. Secant inverse is this one right here. So 1 over the absolute value of u, so that's 2x, times the square root of u squared minus 1. And again, u is 2x because that's what's inside our secant inverse function. And then we're going to have to multiply by du dx. So the derivative of 2x is just 2. Now we are going to do a little bit of simplifying here. So I'm going to put the 2 on the top. And I'm going to leave this square root. So 2x quantity squared is really 4x squared minus 1. And this right here is what I need to talk to you about. So if we have the absolute value of 2x, I can actually take the 2 out and make it just the absolute value of x. Because the 2 is positive, so it doesn't matter. I can take it out of my absolute value signs and just leave the absolute value around the x, because that's what I need to worry about changing the sign of. All right, and then when we look at that, those 2's cancel, which means dy dx is just 1 over the absolute value of x times the square root of 4x squared minus 1. All right, so we're going to do lots of practice with these rules. Again, they are rules that you have to memorize, but we'll do so much practice that you guys won't have really a problem memorizing them. Make sure you wrote some notes if you've got questions, and we'll talk in class when we do some practice. Bye!